Hello everyone, this is our mechanical engineering senior project. Project title is Karaşimşek, which is a low-budget, non-destructive storm drainage inspection car. We are group 17. I am Kemal Güneş, and my teammates are Adnan Mert Trenova and Umut Sercan Sarıcan. Project description: we modeled the parts of our inspection car on Siemens NX. Then we produced our parts using 3D printing method. After that, we adjusted the cable connection inside the design. Then we wrote the code to direct the movement of our car. And finally, we have a design that we can control with a keyboard on a computer and inspect the pipings.
For our design, we prioritize compactability so that we could maneuver around tight spaces and get into the pipes as narrow as 30 centimeters radius. And then we tried to make our center of mass as centered as possible to ensure our stability, which for that we put our heaviest part, which is the battery, in the middle of the bottom plate, which the assembly happened. And then we tried to make our design as water resistant as possible. So we added O-ring between bottom plate and the upper cover. And also we added the fenders.
The part seen in the figure is the bottom plate. Analysis was made against the stresses it may receive while moving in the pipe. As seen in the figure, the places where the engines are located were selected as fixed support. Since there are areas in the system that are in direct contact with a stationary and fixed surface, the areas under the four engines were fixed. The total power that four engines will apply was calculated in Newton and given in the y-axis. Our device moves on a single axis and makes it turns around itself as a tank turn. Therefore, it was assumed that the engines give their power to a single axis, which is y in that analysis. The weight of the part and the gravitational force are the conditions used in this analysis. As seen in the result of the analysis, we got 58,000 Pascal as the maximum stress in the moving axis, which is y-axis. These level of stresses are quite safe and low. Real-life conditions may be much different, but the analysis results reveals that there was no structural weakness, and it was decided to move on the physical production process of the design.
In conclusion, we have a inspection car that goes into pipelines with a camera module, which we control from our computer, which connects with Wi-Fi. For potential future work, we can do bigger wheels, more powerful motors, better camera modules, and completely waterproof the car. Thanks for listening. Special thanks to Levent Demirkazık, which is our own TA in this course, and of course our mechanical lab instructor Mehmet Akif Bey. See ya!